All right, great. Good evening once again, everyone. I trust we are doing well. For waiting quite some time, I assume some of us may be a bit away from our devices. Give me a thumbs up if you are in. Ready Frimpon, Herbert, Abdul Salam, Michael Puti, Bernard. I believe we are all here. Give me a thumbs up if you are in. All right, that's great. Herbert, Abdul Salam, Michael Puti, Bernard. All right. Ready Frimpon, I trust you're also in. All right, good. Today's session is session 26, and you've made some very very good progress from the month of July, August. Today marks the 31st August, and you've made some very very good progress within these 2 months. With all of these sessions scheduled from July to end of August. When we started the session, we began with an introduction, just a very short, very simple introduction to robotics. We didn't want to start by explain defining what robotics is, as if we're going to be writing a theoretical exam, with pen and paper. What is robotics? And then you write robotics is doing this, and no, that's a very boring way of studying. And so quickly we went into YouTube. We went into we took a look at some very simple videos. And even before we started the session, everyone in here, you knew about robotics, you knew these systems exist, but how we can actually start and then build these things, the various components of robotics, how we can simplify it and then know that, okay, if you are going to be working on something, if you are going to be building something, you need to know that the components that make up the system, so that you be at peace with yourself, so that you are clear in your mind, and then you know exactly what you are doing, and then it simplifies everything. So we right from the very beginning, took a look at some of these robotic systems, like these autonomous vehicles, these robotic arms in factories, in these industries that usually are doing these assembly. They are working in a car manufacturing assembly line, and they will be lifting components. They will be lifting heavy stuff from one particular point with accuracy, moving from one particular point to the other. And we'll take a look at these robotic those ones that look like dogs that are used for inspection at very very toxic places, like at nuclear sites, nuclear deposit sites. These things are very very toxic, and so you do not expect human beings to go there. And so they use these robotic systems. They would attach with cameras and all of these things. They inspect by just sitting at the comfort of an office, and then they move these systems to these places and they inspect them. So yeah, right from there, we didn't only take a look at these heavy machinery. We also brought the conversation down to developing products. So you may have something like an airport. We have something like the DJI. I believe everyone in here, you remember. We took a look at the DJI the DJI gimbal, that you can just put a phone on it, and it's able to rotate. It's able to maintain its orientation. And we mentioned that for all of these systems, there are just three things that are involved. It's just mechanical design, electronics, and then programming. So for the mechanical design, that's where you and your team, if you are going to be coming up with a system, you decide that the system is going to be made from metal, or the system is going to be made from plastic, or that some of the parts are going to be made from wood. And so you make your decisions, and then you say that, okay, for this particular part, we're going to be making it from plastic, wood, or metal. And you come up with a design. You do the mechanical design. This part is going to be 10 centimeters. This part is going to be curved. This part is going to have some moving parts. And so let's design some gears that are going to be moving against each of one another, and then giving us some motion. And so that's mechanical design. And then electronics. In all of these systems, there are boards. There are motherboards. Just like when you open our computers, we see a motherboard in there, a green board with all of these components in there: resistors, capacitors, inductors, transistors, more importantly, transistors. All of those components on there, they are working together to ensure that the entire system work effectively. And after doing, and then there are microcontrollers, there are integrated circuits on the board, and some of them are responsible for charging. Some of them are responsible for, even like microcontrollers, we need to write the code onto them. So, we just mentioned, yeah, and I believe you remember when we did a little bit of an introduction to electronics, we did, we mentioned 10 components that are very, very foundational in every electronic system. When it comes to your laptop, your phone, or the DJI gimbal, or those robotic systems. For their electronics, there are only these. I mean, there are these 10 components. These 10 electronic components are always found on every electronics board. And so we mentioned an LED for indication. So they may turn a red light on, or a blue light, or a green light on to signal something for indication, right? And sometimes these LEDs are also used for lighting. So we can have white LEDs, and they may be put, those individual LEDs come together on a panel, and that when powered, gives some huge amount of light to help with work and all of those things. Yeah. So LEDs, and then resistors. We just did a little bit of an introduction to all of these ones. LEDs, resistors, batteries. Then we took a look at a capacitor. We took a look at an inductor. The capacitor just it makes sure that the voltage is stable. An inductor makes sure that the current is stable. And then after an inductor, we took a look at what else? We took a look at a transistor. Yes, a transistor. And we mentioned that in school we usually mention that transistors are used as switches. Transistors are used for amplification, and we do some calculation on transistors, but we do not really appreciate it. How can we use these transistors on boards? How can we use them? How can we actually use them, right? How can we design our own board and then use the transistors on there? And so, just with the introduction, we took a look at the 3 terminals that are found on every transistor. We took a look at 2 types of transistors: MOSFETs and then bipolar junction transistors. For MOSFETs, the terminals that are found on there are drain, source, and gate, right? So you have the source, and we took a look at what these terminals do. For the gate terminal, let's start with the source terminal. So for the source terminal, that's the source of your energy. And so every time you need to connect your battery to the source terminal, and then or wherever your energy is coming from. You just connect your source terminal to the battery, and then you have the drain terminal. And then whenever we mention drain, it's like you have a friend, and always that friend does not buy something when you go out. You always buy something for him or her, and so they are draining energy from your pockets, right? So yeah, it's like someone is draining energy from you. So there will always be a component that will take energy from someone or will drain energy from someone. And so if you have something like an LED or a motor, or any other components, those components, they are going to be draining energy from the battery, right? So we have the source, that's where your battery gets connected to, and then we have the drain. The drain is where you connect your LED to, where you connect your motor to, because those components are going to be draining energy. And then lastly, we have the gate terminal. The gate terminal, just like the name goes, gate. We open gate, we close it to allow. We can either choose to open the gate or we can close the gate, right? So it's like a switch. So the gate terminal, that's where we send signals into. We can send some signal, some on signal or some off signal in a form of current, in a form of voltage for MOSFET, in a form of voltage. And so you can send some 5 volts into it, or 0 volts. You can send 0 volts into it to turn it off. You can send some high voltage into it to turn it on, depending on which type of MOSFET you're working with. But yeah, so we have the source terminal, the drain terminal, and then the gate terminal. The source of your energy, the drain, the component that will be draining the energy, and then the gate. That's where we send signals into, on and off signals. all right, to turn the transistor on or off. All right, and then after MOSFET, we took a look at bipolar junction transistors, BJTs. For bipolar junction transistors, the namings of their terminals are different, but both, these two types of transistors, the terminals, they do the same thing, but it's just like it's just that they have different names. So for a MOSFET, we may have source terminal, drain terminal, and gate terminal. But for a bipolar junction transistor, the names are just different. So for source, the name is emitter. So it's something emitting. So what component will be emitting the energy, right? It's the same as the component where you're going to be getting, your source of the energy. So the component that will be emitting the energy, that's you connect your battery to the emitter, because the battery is what will be emitting the energy. That's it. And then instead of drain, for bipolar junction transistor, they use the word collector, right? So it's the same as the component that will be collecting the energy, or the component that will be draining the energy. And so you connect your LED or your motor to the collector terminal, because these components will be collecting energy from the collector terminal. And then lastly, we have instead of gates, for bipolar junction transistor, it has base, right? BASE, base. So instead of saying gate terminal, it rather says base terminal. And then we also took a look at it. We know that for transistors, we send some on and off signals into it to turn it either on or off. And so for the bipolar junction transistor, it's speaking in terms of it's saying something like, hey, based on which signal do you want to turn me on or off, right? Based on which signal. So you may send some current into it. Something like 50 milliamperes into it, or 30 milliamperes, or 1 amperes into the bipolar junction transistor to turn it on or off. So or 0 milliamperes to turn it on or off. So for the bipolar junction transistor, it rather uses the word base for the naming of that particular terminal, because based on a certain signal, you are going to be turning the transistor on or off. So we took a look at the MOSFET kind of transistors and the bipolar junction kind of transistors. We only took a look at the terminals, just the terminals. We didn't look at how I think we took a look at how we wire them. But we didn't really go into detail. We only connected a battery to the source. We connected an LED or a component that will be draining energy to the various terminals. But we didn't really go into detail how we can use the transistors. But yeah, that was just an introduction, taking a look at the terminals. And then after transistor, we moved on to integrated circuit. That was the eighth electronic component, from LED to battery to resistor to capacitor to inductor to a transistor. And then we took a look at an integrated circuit. So an integrated circuit is just just like the name goes, integrated circuit. It has a lot of circuits that have been fused into or pushed into a very tiny component. And these integrated circuits usually have from 10 pins, from 4 pins and more, right? So 4 pins, 6 pins, 8 pins, 10 pins, all of those. So those components that have multiple pins on them, about 4, 5, 6, those many number of pins, those are integrated circuits. And integrated circuits perform specific functions. We have integrated circuits that are used for controlling a motor, right? We have integrated circuits that are used for charging a battery. So if you are building a battery powered system, you may want to, and in our power banks, if you buy a power bank, there is always an integrated circuit that is used for charging. And we took a look at one of them. It's called TP4056. TP4056. So that's an integrated circuit that is used for charging. And then for the one that is used to control a motor, we took a look at it. But usually, whenever you're going to go for an integrated circuit, it's going to do an actual thing. It's going to do something for you. Yeah. So that was integrated circuit. But when we mentioned integrated circuit, what we focused on was microcontrollers. So microcontrollers are also integrated circuits, because there are lots of circuits that have been integrated or pushed into a very tiny component. So we turn our attention onto microcontrollers. And when we turn our attention onto microcontrollers, we took a look at 2 examples of microcontrollers. We took a look at the ATmega328 right? That's the microcontroller that's found on the Arduino Uno board. And then we also took a look at the ATtiny85 microcontroller. That's a very tiny microcontroller with just 8 pins. And then we went into Tinkercad, and then we did some connections, and then we played around with it a little bit. But yeah, so that was microcontrollers. And when we were speaking about microcontrollers, we needed to learn a few things around about a microcontroller. And we took a look at the pins, right? We already saw that microcontrollers have lots of pins on them. It may have 1, 2, 3, 4, 5, 6, 7, 8. It may have about 8 pins or more pins. And yeah, all of those pins, they are supposed to do some specific functions, right? Just like our hands, our right hand, our left hand, our right leg, our left leg, all of these parts do perform different functions. And so on microcontrollers, with all of those pins on them, they sure are supposed to do specific functions. And so we took a look at those pins. We went into trying to understand those pins. And then we learned that for every component in this world, for everything, there needs to be a source of energy, or there needs to be some energy into it, right? We need to feed some energy into it. So before our laptop is able to turn on, before our computer, our TVs, our electrical appliances are able to turn on, we need to give them some power. And so yes, so for microcontrollers, there is a ground, then the negative terminal, and then the positive terminal. So we need to give it some power connected to a battery. Yeah, and then after power, we also took note of communication pins. Communication pins. We learned that these pins, we have MOSI, we have MISO, we have TX transmit, we have receive, we have all of those pins, serial clock, serial data. We have all of those pins on a microcontroller, and those are used for communication based on which communication protocol or which kind of communication language the microcontrollers are supposed to speak. So we took a look at 3 communication protocols: UART communication protocol, which uses just TX and RX pins of microcontrollers. We took a look at the I2C or I2C communication protocol, which also uses 2 pins, serial data and serial clock of microcontrollers. And so all you have to do is just identify these pins on the microcontrollers, and that's it. You can be able to establish some communication between or among them. And then lastly, SPI, serial peripheral interface. We learned that for that particular communication protocol, it uses 4 wires, MOSI or 4 pins, MOSI, MISO, serial clock, and chip select or slave select. Those 4 pins on the microcontrollers, you can just connect them. And so yeah, and then apart from the communication protocols, we also took a look at general purpose input output pins on microcontrollers. And so whenever you want to input a signal into the microcontroller, you need to connect them to some of the input pins on the microcontroller. Whenever you want to send a signal out of the microcontroller, you need to connect that particular component that will be taking the signal. You need to connect it to the output pin of the microcontroller. And so we learned that the input output pins on a microcontroller, so we can connect sensors to it so that we send signals into the microcontroller. And whenever we want to send signals out of the microcontroller to control something, then we connect that particular component to some of the output pins, and then we can do it. And we also appreciated that some of those pins can do communication. They can do inputs, they can do outputs, they can do analog, they can do digital, right? If you can look at, we just appreciated those things a little bit. And after discussing, yeah, so microcontrollers, integrated circuits, microcontrollers, and then we discussed a little bit around diodes, right? We mentioned a little bit around diodes. So diodes allow current to flow in only one direction, yeah. But we've not really appreciated all of these electronic things, electronic components really, really well, as in how we can just get a microcontroller and really work with them, or add a capacitor to it, add a resistor to it, and then do all of these, very, great stuff, very good projects with what we have learned so far. But yeah, after mentioning microcontrollers, discussing the hardware aspect of it, what we call pin out. Microcontroller pin out. The microcontroller pin out is just the the pins on the microcontroller, what they do, the functions that they do. That's what we took a look at. Power, ground and positive terminal, and communication, and then input output. We took a look at that. After taking a look at the hardware of microcontrollers and then taking a look at the communication, you now set out on to learning how we can write instructions onto the microcontroller, right? How we can write instructions onto the microcontroller, and that's when we went into programming. So programming microcontrollers, how do you do it? It's just programming a microcontroller just centers around 5 things. I believe you've got a very simplified introduction to programming microcontrollers. We mentioned that the first thing, whenever you build a system, the system is supposed to generate some data. There are obviously going to be some sensors. A user is going to press a button, and whenever a user presses a button, there are some signals that will be generated, and we need to record that signal. We need to keep the signal in a kind of a container or something. And so you learned about variables and data types. That was the first thing you needed to learn, so that whenever you connect a sensor to whenever you connect sensors to your system, the data that come out of those sensors, you can store them in containers. So variables and data type. Data types just tell which type of data. Is the data in a form of numbers? Is the data in a form of decimal numbers? The data in the form of negative numbers, just positive numbers, unsigned, right? Unsigned numbers. So just positive numbers. And you take a look at data types. Is the data in a form of letters or alphabets? In a form of username or password or something. So you took a look at variables and data type. That was the first thing. And then for the second thing, conditional statements. So after getting the data, you need to make some decisions to say that, okay, when the sensor is giving us 10, a reading of 10, a sensor value of 10 or 50, we want to do a certain action. So if the sensor value is greater than 100, we want to turn the light on. If the sensor value is less than 2, we want to turn it off, something like that. So you needed to learn how to make decisions. And so you learned about conditional statement. The first thing you learned was if-else conditional statements, and then you took a look at switch case conditional statements. So these two conditional statements are used to make decisions. So that was it. After studying appreciating conditional statements, you then took a look at loops. Loops is when we want to, how many times we want to perform an action 10 times. So we use loops. You took a look at about you took a look at the 3 types of loops we have: for loop, while loop, and do while loop. So for the for loop, that's when you know how many times something is supposed to happen. 10 times, 15 times, then you use the for loop. And then for the while loop, that's when you want an action to happen. That's when you want an action to happen forever if the condition is true. If the condition is true, you want a certain action to run forever. The action is going to stop when the condition becomes false. So so far as the condition is true, the action is going to run forever. That's the while loop. While the condition is true, we want to do this action forever until the condition becomes false. Then that particular while loop stops. And then we took a look at do while loop. And then for the do while loop, we appreciated we have 2 words in there, do and then while. So for the do, that's where we put the action. We put what we want to do. So we use an example. We use a very funny good example. And that was a soldier, an army person, or a military person. So he comes straight to you. He's not going to ask whether you are the one that stole the phone or did not steal the phone. What he's going to do, what he has planned is, he's going to slap you first. So he's going to slap you once first. So after slapping you, then he's going to ask you whether you are the one that stole the phone or not. So if you then tell him so before you even explain yourself, before he asks you the question, he's going to slap you first for just one time. And then after that, then he asks you. So depending on the answer that you give, so if you are the one that stole it, then he will continue slapping you. If you are not the one that stole it, then he's going to stop. But even though you are not the one that stole it, you would have received the first slap. And that is used in systems like in systems where you want to perform an action at least once before you check the condition to see whether it's true or false. And it may be It may be printing something like what is your name on the screen before a user types in their name, right? So that is that's not a very good example. That is not a do while loop. Let's see. Do this while do this. That's the action once first, and then after that is going to ask whether it's true or false. But yeah, we're going to be appreciating, and this why the practical sessions, the practical stage of this program is going to be very, very important. But you have all of these components, you're going to be appreciating all of these things. But that was loops. After considering loops, you then took a look at functions. When you want to create a piece of code that is going to be reused multiple times. So that was functions. We took a look at built-in Arduino functions. The Arduino is just a platform for robotics, a platform for electronics, a platform for programming. And so for the Arduino platform, for the Arduino programming language, there are certain built-in functions. There are certain things, there are certain keywords that are used in programming that simplify stuff for us. And so something like digital write, digital read, something like analog write, analog read, something like pin mode. These are specific words. These are keywords. And then for those built-in Arduino functions, we also used a very, you got a very good strategy for not wasting time. Do not waste 4 years trying to learn everything about built-in Arduino functions. No, you don't have to waste that time. And you also, you may spend about 2 years studying built-in Arduino functions. Meanwhile, you still be feeling like you do not know enough, or you cannot build anything. So that is not that particular condition, that particular feeling, that particular situation, that particular kind of education, that particular kind of studying stuff is not good at all. All you have to do was just get a classification or a category of built-in Arduino functions. There are functions that are used for built-in Arduino functions that are used for timing. There are some of them that are used for math stuff, like getting square root or square root of a number. There are some of them that are used for serial communication. And so whenever you connect a microcontroller to your computer, you want to establish serial communication between them so that you can be able to see exactly what's happening in your microcontroller's brain. Right? After writing your code onto it, you can tell it to print a certain message onto the screen of your computer. If you can even, after connecting a sensor to it, you can print the values of the sensor on the screen so that you see, exactly what's happening in the microcontroller's brain. So that's serial communication. So there are certain keywords, there are certain built-in Arduino functions that are used for these things. And functions only take parameters. So for something like digital write, for that particular function, it's going to take just 2 parameters, the pin number and then the signal that you are writing. So the signal that you are writing or sending onto the component, onto the LED, right? So if you write digital write, then you bring your bracket open, bracket close, and then you write the first thing. That's the pin number. Which pin number you want to write a signal onto, right? And when you write a signal onto that pin, the component that has been connected to the pin will receive that particular signal, right? So it can be high, it can be low. So you can write, the second thing you do is after writing the pin number, you bring a comma, and then you write high or low. So yeah, that's it. And when you say high or low, it's going to send a certain voltage, a certain signal, whether 5 volts or whether 0 volts. So high or low, right? Into that particular, onto the pin, and then into the particular component. So that was digital write, digital read. So some functions, some built-in Arduino functions are used for serial communication, are used for timing, are used for math, are used for there are various categories, and we take a look at all of those categories. So you don't have to spend a whole lot of time knowing all built-in Arduino functions. All you have to do is just know know the categories. And whenever you're working on a project, you just do a little quick search, and then you're able to figure out which type of function you're supposed to use, and that makes everything simpler, right? So you have the confidence that you can build projects. All you have to do, you understand the categories. All you have to do is just do targeted research. Which functions can I use for timing? And then you just do a quick search, and then you see the millis, you see micros, and then you're able to use it. So simple. And yeah, after taking a look at built-in Arduino functions, we took a look at how to create our own functions. And it was so simple. I just give the function a name, you put the parameters in there, and I believe everyone in here, you appreciated that. So that was functions. And then the last then is libraries. So libraries is just a file, a full file, just like your Arduino code, right? It's like a full file that has lots of code in there, and then it simplifies how we can write the code. So with a library, when we download the library and we install it, and then we include it into our code, we just write hash include, and then we write whatever, how it's supposed to be done, right? And then that's it. We have included the library, the file in our code. So that's it. And then it simplifies everything. A library has lots of functions in there. So with a library, with that particular file that has 200 lines of code in there, we can just import it or add it into our code. And what it does is we are able to use the functions in that particular library, right? The functions that have been created in that particular library. So you can just write just one line of code, and we're able to do lots of things, right? Meanwhile, if we were not using the library, we would have written all of those 200 lines of code, right? We would have written so many lines of code to just do one tiny action. But with a library, we are able to, be fast. Engineers are able to be so fast. If you're working on a project, you can quickly finish it, and you do not have to waste lots of time writing lots of code and then analyzing lots of things, right? So that was library. So these 5 things are just the things around programming. Whenever I want to program a microcontroller, for all of these systems that exist that use the Arduino programming language, it's just these 5 things: variables and data types, conditional statements so that you make decisions, loops, and functions, and lastly libraries. So these 5 things, that's it. So simple. And once you are working on your own project, you can you can specifically write your loops. You can specifically create your variables and variables with the appropriate data types. You can write your own loops. You can write your own functions. You can import libraries into it. And we're going to be taking a look. We can we've appreciated all of these things, but if we want to appreciate them really, really well, that's when we have the physical components. We can connect things. We can write the code, and then we can write some for loops. Like we mentioned, whenever you want to write an algorithm an algorithm that will perform some actions. Whenever you're writing something like a PID algorithm that will be doing proportional, integral, derivative, those things that we studied in calculus. You need to create an algorithm that is going to be performing some complex stuff. You need to write a for loop, and then write another for loop in that particular for loop, and then write another for loop in that for loop, to do things, whether 5 times, 6 times, you write a while loop, you put it, so nested loops, lots of loops in loops. And you're going to be appreciating all of these things once we get our physical components and we are working with them. So that was programming. And then now, so we took a look at these electronic components, the 10 electronic components that we mentioned when we're looking at the electronics. So we took a look at LED, resistor, battery, diode, capacitor, inductor, integrated circuit. What else? Integrated circuits. What else did we take a look at? And all of those ones, right? After taking a look at integrated circuit, we took a look at microcontroller, and that's what took us into microcontroller programming. Now we need to come back to all of these components, especially capacitor, resistor, transistors. These are very, very important. Capacitor, inductor, transistor, diode. These 4 components are very, very important. How we can combine them, especially transistors, how we can combine them, how we can use them. You can combine resistors together, and then we create something like a voltage divider. And I believe everyone in here, if you study electronics, you know about a voltage divider. And we can use a voltage divider, connect it, the signal that is coming out of a voltage divider into a microcontroller, and we are able to read the signals to monitor the battery level of your system. So for a phone, you're able to get the percentage of the battery, like 86%. If it's 90%, you're able to see all of those percentages on your phone. How do we do it? with using a voltage divider, just 2 resistors or 3 resistors. You connect them together and you're able to do it. So it's now that you are going to be appreciating all of these using the components really, really well. And transistors, how do you use them for amplification? How do you use them for switches? And to understand these things really well, they need to work with a microcontroller. Most of them need to work with a microcontroller, and so that's why you got a very good you got a quick programming on microcontrollers. How to depends on a microcontroller, the communication stuff on a microcontroller, so that once we come back onto these components, considering them really well practically, you're able to appreciate them really, really well. And so now is a practical time where you're going to be using all of these components from your SIR kit. And in our last session, that was yesterday, Saturday, so session 25, that's when you took a look at how a microcontroller can connect, how a microcontroller, if you have a bare microcontroller in your hand, if you open up your computer, or if you open up a destroyed product, and then you just take one of the microcontrollers from the board, those black components, when you take it from the board, those microcontrollers, you take one microcontroller from the board. How do you get that particular microcontroller, single microcontroller in your hand? We know a microcontroller just has pins on them. So how do you get a microcontroller to connect with your computer, so that after writing all of your code, after writing your variables and data types, after writing your conditional statements, after writing your loops, after writing your functions, after adding some libraries into it, writing your code for your system, how do you get that particular code from your computer onto the microcontroller? And before at the end of the session, you took a look at some simple stuff, and I believe everyone in here, you've appreciated them already. And that's for low-level programming languages like C++, and Arduino is just simplified C++. C and C++ combined, the features of these programming languages have given birth to a new one, Arduino programming language, a simplified one. But it has words in there, it has pin mode, it has begin, it has words in there. After writing all of those code, your code needs to be compiled. The code needs to be compiled into a hex file, right? Into machine code, into just zeros and ones. And I believe everyone in here, you appreciate it. We always mention that electronics, machines, they just speak zeros and ones, right? So our computer, our microcontroller will not be able to understand all of the code that we write, all of the pin mode, digital write, the serial.begin, all of those things, all of those human readable instructions that we have written, the microcontroller will not be able to understand. What it's going to understand is just zeros and ones. And so Arduino IDE, the software that has been created, needs to compile the code. It needs to convert the code. It needs to process the code into a hex file, into a machine code, and then we can now send it onto our microcontroller. And so that was it. That was a very, very quick one. And then we also appreciated, I believe everyone in here, you're not going to forget this. Whenever you have a microcontroller like that, like what we can see on our screen, there's a tiny something. There's a tiny, amount of consciousness that is in the microcontroller, so that when you write your code onto it, it's able to accept it. And that's what we call bootloader. Bootloader, B-O-O-T, boot, and loader, L-O-A-D-E-R, right? So boot and then loader. And usually when we turn our computers on, we say the computer is booted, right? So yeah, that little code, it's usually written in a very, very low language code, usually in C programming language or in assembly language. And it's quite hard to write those code, those low-level programming languages. And you have to write a whole lines of code to perform just one tiny action. But yeah, so we have something called a bootloader, and it's just C or assembly language code. It's just a tiny code that has already been fixed into the microcontroller, and it's just occupying a very small part of your flash memory of the microcontroller, and it has been stored there. It has been just buried in there to give the microcontroller something like some amount of consciousness, right? So yeah, that's it. That's bootloader. And then once your code gets uploaded onto it, the bootloader is able to say that, hey, welcome. It welcomes the code that you have written, and then it says, hey, code, you can now take over, and then just let the microcontroller work. So microcontrollers have something called bootloader, tiny program that has been written in it, and that helps it be able to accept code from us. But yeah, so in our last session yesterday, we took a look at how we can connect a microcontroller to our personal computer, to the computer, so we can send the code that we have written in our Arduino IDE onto the microcontroller. So the first thing we saw was that the first thing we got to appreciate was that microcontrollers speak a different language, and our computer also speaks a different language. Our computer speaks USB language, USB. So like a USB cable, it speaks USB language. If you want to connect a mouse to your computer, it has to be via USB. If you want to connect a keyboard to your computer, it has to be via a keyboard, it has to be via a USB cable, a USB something, right? If you have to connect a monitor to your computer, it has to be using, something, a connector, right? And our microcontroller just has pins on it. How do we connect this microcontroller to this computer? We cannot do that, right? But the only way, and even understanding that the microcontroller speaks UART language, it speaks UART language, and we consider UART as a communication protocol, right? And it uses TX and RX to communicate with other microcontrollers. But now we want the microcontroller to speak with a computer. So since the microcontroller speaks UART language and the computer speaks USB language, we need a translator. We need a chip, an integrated circuit that is going to be converting UART language, that is going to be converting the computer's USB language into UART language, right? Yeah. So so we do that using a USB to UART chip, or a USB to UART integrated circuit, IC, right? And that's we took a look at two examples. CP2102. That's the one we can see on our screens, and there's one also called CH340, right? But usually, you can just use a CP2102. We're going to be appreciating all of these things, especially when we're designing our own boards, right? But yeah, you get this particular component there, and all you have to do is just connect your TX of the microcontroller to this particular component here. You connect TX of your microcontroller to this one, RX to this one. That's it. You're done. And then you get a type C female connector, right? And this type C female connector, even though we do not see wires on it, there are pins. There are wires in there, right? There are 4 pins in there. You have the positive terminal. It's called V bus. The positive terminal on the type C connector, it's called V bus, right? And then we have the negative terminal, ground. And then we have two pins in the middle. So it usually looks like something like this, right? So here will be the V bus. Here is going to be the negative terminal, and then the two in the middle, one of them is D minus, and then one is D plus. Those are used for data minus and then data plus, right? So that's it. So on this USB to UART chip, there are D minus, there is D plus, and there is positive terminal, there is V bus on there. So all you have to do is just connect a female port, a female USB port, type C USB port to the USB to UART chip, and that also connects to the microcontroller, and that's simple. So you connect your microcontroller to the USB to UART chip, this one here, and then you connect a USB type C port to it, and then that's it. And then that's it, you're done. So now what you can do is, using a USB cable like this one, you can connect the type C to the type C. You can connect the type C male port here to the type C female port, and that's it. And then you connect that the A port here to your computer, and then that's it. You have established communication. So that's it. You just need a USB to UART, a translator chip, right? So you connect the chip in the middle, you connect the type C to the chip, connect your microcontroller to the chip, and that's it. And then you have given so you have given a microcontroller. It's like, these three things have now become one, right? These three things here have now become one, because it's like now the middle man here has connected this and then this together. So now your microcontroller has a USB, right? And then that's it. Now you can connect it to your computer using a USB cable. So simple. But lastly, the final thing we took a look at is after getting the hardware setup done, after connecting your microcontroller to the USB to UART chip to a female port, that's the hardware stuff. You now need a software. Just like so many other peripherals or devices, for a mouse, you build a mouse and then you connect it to your computer. Your computer is not going to usually recognize it immediately. To get your computer to recognize it, right, your computer also has an operating system. It has a Windows operating system or a Mac operating system or a Linux operating system. These are operating systems. After turning on your computer, after your computer boots up, the operating system is taking control of your entire hardware. And so if you connect a mouse to your computer, it's the operating system that needs to identify that you have connected a mouse into the to the computer via a USB cable. And the electronics in here, there needs to be a USB to UART chip in the mouse, in the keyboard, in whatever component you connect to your laptop. And that particular chip in a mouse or in the keyboard or in the peripheral needs to be recognized by the operating system, by a Windows operating system. And so usually if you use a CP2102, this particular USB to UART chip we are seeing here, usually Windows operating system, it's going to usually most operating systems, Mac operating system, Linux, depending on which operating system your computer is running, it will be able to immediately recognize the CP2102 immediately. So if you build a mouse with this CP21, if you build a microcontroller with this CP21, immediately you connect it to your computer using a USB cable, it's just going to recognize it, right? But there are some chips, there are some translator chips that that require that you install a library on your computer, so that your computer, the library is just a file. It's just some C++ code or C code that have been written, right? And then it tells your operating system, it tells your Windows operating system how this chip works, how this chip communicates, right? So that your Windows operating system is able to communicate with the USB to UART chip. So that's simply it. So if you're working with a USB to UART chip like the CH340, usually that particular chip, it's not really recognized by other operating systems, right? You may always get a trouble. You may always there may always be some, the computer the operating system not recognizing it. And so you need to go onto the website of the manufacturer of that USB to UART chip, and then you go to their website and then you download a driver. Sometimes for most other components or devices that you connect to your computer, like a mouse or a keyboard or a monitor, when you plug it into your computer, your operating system may not recognize it. And so you have to go onto the website of the manufacturer of that particular device, and then you download a driver onto your computer, you install it onto your computer, and then your operating system will be able to communicate with that device. And so it's the same way. When you're working with a CH340 USB to UART chip, you have to download a library onto your computer and then install it, so that your operating system is able to communicate with the USB to UART chip, right? And then that's it. And since your microcontroller has been connected to the chip, now whatever instructions you write on your computer, you can be able to send them, right? First, it processes your code into a hex file. It processes your code into a machine code, and then it sends it through the USB cable, right? It sends it through the USB cable into your microcontroller that is found in your mouse, right? So you can build a mouse with a microcontroller, and then for your mouse to get recognized by your computer, you need the CP2102, so that you can connect it, so that you can give it a USB cable. Yeah, so that's it. So simple. And so yeah, that was the end. So from the start, you learned that for robotics, mechanical design, electronics, and programming, And as of now, you have done a little bit of programming. And even for mechanical design, you've made some good progress. In Fusion 360, you just do sketches and then you extrude. You do sketch on top of the surface and then you extrude. And then you're able to create some holes, able to create some features. We do not really go into detail. But at least you've made some very, very good progress. Give me a thumbs up. Give me a thumbs up if you've made some very, very good progress so far. Give me a thumbs up. All right, Michael Okoti. All right, that's great. Bernard. All right, Abdul Salam. That's great. All right, Herbert. I trust you've made some great progress. Roddy. All right, Roddy. That's great. That's great. So far you've made some very, very good progress. But you need to now appreciate all of these things really well. Now it's a matter of building projects. So that's why your SIR kit has lots of microcontrollers. First, it has microcontroller boards. It has an ESP32 board. It has an Arduino Uno board, and then it has the bare microcontrollers. Just the microcontroller, just like this one on our screen. Just the microcontroller, right? You can take the microcontroller, put it in your hands, and when you are able to work with the microcontroller, now you can open a destroyed TV, and then you just take the microcontroller from that TV board or that destroyed computer, and with the knowledge that you have gained, you can be able to work with But yeah, there are bare microcontrollers in your SIR kit, and now you can be able to work with them. And then there are wireless components. There are wireless modules in the SIR kit, NRF2401. You have 2 of them. So you can use your small ATtiny85 microcontroller. I have 2 of them. So you can attach the wireless module to one, and then you attach a wireless module to the other one, and then you can use one as a transmitter, and then the other as a receiver. So you can build a drone. Now, if you want to build a drone, how do you use these 5 programming things that we mentioned? Loops, variables and data types, conditional statements, loops, functions, libraries. How do you join these things together? How do you write some good algorithms that are going to be, PID algorithms that are going to, in drones there are PID algorithms, and you need to let the drone be able to stabilize itself. You do not want one motor to rotate so much, and we need to have some components like IMUs, inertial measurement units, and there are all of these components in your SIR kit. So it's now a matter of working on projects, working with these physical components that you can be able to, really appreciate these things, starting from simple projects with the components in there to some advanced projects. So you have GPS modules in there, you have some OLED displays, and you can do some wonderful stuff. And so, now we're going to be getting a little break, but it's not really a break. We're going to be getting a little break, but it's not really a break. So that it's just with regards to payment. We're going to be getting 2 weeks from today. Today marks the last session, session 26 of at least making some very, very good progress. So you're going to be getting 2 weeks, or just a little bit amount of time, so that like we mentioned, even if it's a very good strategy, even if it's about finding about 9 friends. And then you go to one friend and you say, hey, please give me 100 CDs. I'm going to be giving 100 CDs to you later. And then you go to another person, you get 100 CDs, right? And then you put these together from the 9 students, right? From your 9 friends, and then you have 900. You get another person in addition, so you can have 999 CDs, right? Very, very great investment for the great progress you need to make for all of these components in there, for the stepper motor. Like I mentioned, these are industry grade components. We can see a 3D printer behind me. It has green colors on it. I'm unsure we can be able to see the 3D printer behind me, but the components, the stepper motors that are found in your kit, in your SIR kit, these are the same stepper motors that are found on actual systems that work, actual products. And so they're going to be making some very, very good progress. So just it's a very good strategy. You can go, if you're not with money as of now. Just use this strategy we're giving you, because it's a very, very good investment for for your being able to build projects. And then what we are going to be doing is, so far, I am unsure that everyone in here, from the introductory session to now, you've consistently updated your social media with the progress that you are making. But it's a very, very important thing you need to do. So, but what you're going to be doing is, throughout the practical sessions, with the components that you're going to be having in your SIR kit, you're always going to be recording videos of the projects that you are working on, and then you posting them on your social media pages, the progress that you are making. And then very, 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 very soon, you're going to be watching these videos, the project that you have built yourself, and you're just going to be appreciating yourself. And it's going to bring lots of opportunities to your own self, right? And most of you are in the universities, and you're going to be working on your final year project. So this is a very, very good investment. Just if you have just some amount of money on you right now, just keep it. And then the strategy is, go to friends, just get these amounts. These are tiny amounts, so none of them are they're not going to be feeling it, right? So just get it, put them together, and then just procure your SIR kits, and that's it. That's a great investment for you. All of these components in there, you can work on your project. And you record them, you post them on your social media. That's a great testament to what you can do, what you can do. And apart from that, in your end of year project, in school project, you, after working on all of these projects from the Simplified Introduction to Robotics program, it will be so easier, and you're going to appreciate this. It's going to be so easy. And since you have the physical components, you are going to be able to do to work on a very solid project that is going to earn you some very, very good stuff. But the most important thing is you being able to with those projects that you work on, some complex projects, you be able to get opportunities. You go into a company, you just spend a little bit amount of time, you do more stuff, and then you give them progress, and then you grow as a person. And then after it, you can start your own company that is going to be producing products that people are going to be buying. And we're going to be doing a little bit of Internet of Things. How I can press you can build an app and then connect it. How you can build an app? You can just write some a website. You write some HTML, CSS, JavaScript. You write some backend with Node or Python, and you host your website or your web software on AWS. And after hosting it, you can build a database on that server, and then you connect everything together. You connect it. You give your electronics access to internet. So you may, with the ESP32, or you may connect a cellular module to the component, and you're able to connect it to the internet. And then with the app, which can be accessible to so many people, you can just press a button and then it turns on or turns off. So you can there's great stuff you can do with your SIR kits. Very, 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 very good investment for you. And so we're going to be opening this within some amount of time. That's just the break. The break is just for you to use the strategy, get the investment you need, the money you need, the 999 CDs. Just get your SIR kit. That's just the break. But now we need to do a little bit of we need to go into we're going to be, for the meantime, for these 2 weeks that you're going to be finding your source of your money to procure your SIR kit. For these 2 weeks, you are going to be working in a simulator. There's something called FileStat. There's and Tinkercad. So we're going to be using Tinkercad. We're going to be appreciating transistors, how they work, and all of these things. We're going to be writing the code. Now that you know how to write code, with these five things, we're going to be writing some good stuff, and then you'll be appreciating them a little bit as you wait for your as you wait to make full payment for SIR kit. And then in just a short period of time, you'll be having your SIR kit delivered to your various locations, and then you can work with all of the components in there. And then you are going to be working on projects. Like we mentioned, the drone project. You're going to be working on all of these things, and then you make some very good progress. But yeah, let's not extend this. Do we have any questions? One or two questions we have, short questions. Abdul Salam, do you have a question? Ready? Michael Oputi, Herbert, Bernard. All right, Abdul Salam, please go ahead. Please go ahead, Abdul Salam. It looks like you are muted.
I'm saying, okay, sorry, I muted. So, like, does that mean that we are not going to be connecting or having online session for this 2 weeks?
Give me a thumbs up or thumbs down if you are done with your exam or still doing exam. If you're done with your exam, give me a thumbs up. If you are still doing exam, give me a thumbs up. Okay, Bernard is done. Ready from point, still working on exam. Michael Oputi still doing exam. Okay, and it's Abdul Salam. All right, that's good. So all right. So this is what we're going to be doing. This is what we're going to be doing. Everyone is just going to be going. Silence isn't really great. Silence isn't the silence isn't really great, but but all right, so this is what we're going to be doing. This is what we're going to be doing. We're going to be going on a very short break. This 2 weeks break. What you're going to be doing is, and I trust by within a matter of 2 weeks, exam will be done. Otherwise, will exam be done in 2 weeks? All right. All right. All right. So in 2 weeks, exam will be done. That's another aspect that is quite important. Even though, yeah, if it's important, exam is important. I just do not like the idea of just writing paper pen exams without the practical stuff we are doing. But it's also important. So within these 2 weeks, at the end, today's session is session 26. So 2 weeks, you just have some break, but announcements will be made, and a document will be shared. So within the following weeks, communication, clarity in communication, further communication will be on our Google Classroom and on our WhatsApp, so that what to expect. But there's going to be a break, and from next week you're going to be getting the payment platform, whether through bank or mobile money, which is quite accessible to quite simple for everyone. You're going to be making payments, and in at the end of the break we resume, and then we now do some simulations, some very good simulations, and then after that you have your physical components, and then you can be able to work with them. So yes, for how long the break is going to be, further communication will be made on our Google Classroom and on our WhatsApp. So please watch out for that. And also the payment method, it's going to be in the user strategy we have mentioned. Do not waste time do not waste time at all trying to find original capital to invest in this SIR kit for your own SIR kit. Use the strategy. It's very effective. All of these 9 or 10 friends are not going to go to a meeting and then know that you took 100 Cs from them. Very effective. So you can just get 100 Cs from each, and then you just put it together, invest it into your own components, and then you make some very good progress. And yeah, do we have any more questions? But yeah, we're going to be getting some break, and hopefully you can be able to focus on the exam. And once you resume, you're going to be you would have already made payment for your SRR kit. It's going to get shipped to you, and you make some practical progress. But before the practical progress, we're still going to do some very important simulations on transistors, on resistors, voltage divider, how we can do them, and then we'll finally have our SRR kit, and then work on the drone projects and all of these projects that we have mentioned. But any more questions? Any more questions? I trust you're good, Abdul Salam. I trust you're good, Abdul Salam. Anyway, any more questions from us? Michael Oputi, Herbert? All right. Ready? Bernard, do you have any question? Ready? Michael Oputi, Bernard. All right. Yeah, all good. All right. All right. All right. Then on this note, let's bring session 26 to a close. We're all going to have a good break and expect the communication on a WhatsApp and on Google Classroom. The payment method and communication with regards to break and the further progress. But yeah, I believe everyone in here you've made some very good progress at this point. But yeah, we're going to be making more progress practically using actual components. But yeah, let's have a very good evening. We're going to be connecting via communication on our WhatsApp group. Bye everyone. Bye.